Now, what is the pH of 0.18 molar of sodium acetate at 25 degrees Celsius, given the Ka of the acid, which is 1.8 multiplied by 10 to the power of negative 5. So we are given sodium acetate, which is a base, and we are given the Ka of the acid. So when we're given sodium acetate, which is a base, we have to use Kb. So we have Kb of the acid, concentration of the acid, multiply that by hydroxide ion divided by the concentration of the base. Now let's write the chemical reaction. So we have sodium acetate. We're going to add water to it. So we have sodium acetate C6H5 COONA aqueous plus H2O, and that gives us C6H5 COOH plus the hydroxide ion. Note that the sodium ion does not react in water, so you can leave that one out if you want. You can leave it out just like that and put a something like that minus over there. So from here we can write our, we can draw our reaction table. So we can do this. So we have initial, change, and equilibrium. So we are given the initial concentration for sodium acetate, which is 0.18. Water is out, and we do not have the concentration of the acid yet, and the concentration of the hydronium ion, hydroxide, sorry. So now we have the change. We don't know what that is, but we just label it X, and then we have positive X here and positive X here. So that will, at equilibrium, that will be 0.18 minus X and nothing there. So here we have X and we have X there at equilibrium. Now we have to find the hydroxide concentration. How are we going to get that? So we already have the Kb. So we have Kb expression, which is the concentration of the acid, multiply that by the concentration of the hydroxide divided by the concentration of the base. So to find the Kb, we can use the Ka, which we got in the question. So we can just go up. So we have the Ka, which is 1.8 multiplied by 10 to the power of negative 5. So the Ka is equal to Kw divided by, sorry, we're looking for Kb. Actually, Kb is equal to Kw divided by Ka. So which is equal to Kw is 1 multiplied by 10 to the power of negative 14 divided by the value of the Ka, which is 1.8 multiplied by 10 to the power of -5. And this gives us a value of 5.6 multiplied by 10 to the power of -10. Now that we have the value for Kb, we can put it into our equation. So we have 5.6 multiplied by 10 to the power of -10 is equal to the equilibrium concentration of the acid, which is X, and multiply that by the equilibrium concentration of the hydroxide ion divided by the equilibrium concentration for the base, which is 0.18 minus X. Now from here we can multiply out by the denominator, which is 0.18 minus X, or 0.18 minus X. So that will go, and now we have 5.6 times 10 to the power of -10, multiply that by 0.18, and that gives us 1.008 times 10 to the power of -10 minus 5.6 multiplied by 10 to the power of -10. X is equal to X squared, so we can take that X squared to the other side, so we have X squared, and now we have that. So now that we have this type of equation, so we can just plug it into our calculator, and we found out that the concentration of the hydroxide ion is 1 times 10 to the power of -5. So now that we have the concentration of the hydroxide ion, so we can find the pH. So how are we going to do that? So we have pOH, because we are using the concentration of OH. So we say pOH is equal to negative log of the hydroxide ion concentration. So we have negative log of 1 times 10 to the power of -5, and that gives us the value of 5. So now that we have the pOH, we can find the pH. So we have something like this. So 14 is equal to pOH plus pH. So basically pH is equal to 14 minus pOH. So the pH is equal to 14 minus 5. So we have 14 minus 5, and that gives us the pH of 9. So when we go back to the question, it makes sense that the pH is 9 because sodium acetate is a base. And that's your final answer.